the sum from n equals 1 to infinity of -1 to the n over n factorial. So this definitely converges by the alternating series test. The signs alternate from the -1 to the n. The terms are decreasing towards 0 because that denominator is getting bigger. So this converges by AST. Then we have to check absolute value of the series, which is just 1 over n factorial, using the ratio test. Factorials scream ratio test. So the ratio test says take the limit as n goes to infinity of a sub n plus 1 over a sub n. And if that comes out to a value less than 1, then we get convergence. Greater than 1, we get divergence. Equal to 1, we know nothing. We have to use another test. Okay, so this is the limit as n goes to infinity of -1 to the n plus 1 over n plus 1 factorial. Instead of dividing by a sub n, I'm going to multiply by its reciprocal. So we have n factorial over -1 to the n. So -1 to the n plus 1 over -1 to the n would reduce to -1. And then n factorial over n plus 1 factorial. Maybe we'll write out a few terms here. So n factorial is n times n minus 1 times n minus 2 down to 1. And n plus 1 factorial is n plus 1 times n minus 1 down to 1. All right, so I still have my -1, but it doesn't really matter because I'm going to take the absolute value of it. So I think I'm just not even going to write it down. Yeah, because I'm going to take the absolute value right now. Oops. Okay, so my n's are all positive, so that whole fraction with the factorials is positive. My -1 absolute value becomes positive. So I'm going to get a bunch of canceling here. And I get 1 over n plus 1. And the limit as n goes to infinity of that is 0. That is less than 1, which means we have convergence. So the original series converged. The absolute value of my series converged. Oh, I didn't need the -1s in there. I should have had these all be positive ones because I was checking 1 over n factorial, not the original 1. There we go. Comes out the same. So the absolute value converges, which means we have absolute convergence. Converges absolutely.